Right, so 我们会讲到 Pascal Principle. Hydraulics. Right, so let's say when you are trying to fly an airplane, there are many control surfaces. Three types of motion: rolling of the airplane, pitching of the airplane, nose up, nose down, and also the yawing motion. All this motion, right, is controlled by the flaps, the slats, the ailerons. Maybe you have heard all these control surfaces on the wings of the airplane. Huh? So how do you control this one? With just one touch, one button. Same for the car braking system. You press the pedal, then the brake pads, again, they come together, they stop the wheels. All this cannot happen without hydraulics. Okay? So again, hydraulics is used as a force multiplier. What do I mean by force multiplier? You need to apply force to control all these surfaces. You need a very large amount of forces. So how you apply that is the help of hydraulics. So same for the car braking system, you step on the pedal, you put your foot on the pedal, small force, then the force is amplified to the four wheels of the car. So we see how it works. I'm going to draw a diagram. In the hydraulic system, you got two pistons. One small piston, another one larger piston. Let's say we draw. We have a cylindrical piston, area 1, smaller piston, and then we have a larger piston. Now, in between this piston is completely closed. Okay, no air can go in, no air can go out. We fill all this with hydraulic oil. It's all airtight. No air bubble can go in, no air can dissolve inside this. Now, we have an enclosed system filled with oil. Remember in the last lesson we talked about what's the difference between liquid and gas? Many differences, right? The particles, arrangement. But the main thing we want to talk about here, the main property that we use liquid as hydraulic oil. We use hydraulic oil in the hydraulics is because liquid is incompressible. Gas is compressible. Meaning that you can compress gas. Because gas particles, they are very far apart, right? Particle and particle very far apart. You can compress them, you can squeeze them into one tiny volume. But liquid, you cannot do that. Liquid, the particle is like solid, very, very close. Solid is the closest, liquid is just slightly further apart. It's still very close. If you want to compress it, still you cannot compress it. There's not enough spacing for you to compress. So liquid is incompressible. Now, what about incompressible? That makes it fit to become the hydraulic fluid. One thing is that if it is incompressible, you cannot change the volume. Okay, volume is fixed. Sorry, should be density. Let me correct this one. Density is fixed. Density is equal to what? Mass divided by volume. Okay, so if you cannot compress it, that means the amount of mass inside here per unit volume is the same. Let's take an example of if it was gas. and I compress the gas all in this container. Initially, the container got 3 particles. So you have a fixed volume V, and then you got 3 particles giving you mass M. You have a certain density, right, of the gas in the container. If I compress all the gas, I squeeze the gas into the container. So now I get more and more particles. What happens is that the mass will increase. Okay, because there are spacing between the particles, that I can fill more particles in by squeezing in, by compressing. Okay, so if I compress all the gas inside, then I have increased the density of the gas in the container. So that means, in short, I can change the density of gas. But can I change the density of liquid? I cannot change the density of liquid. It's already fixed. Because the incompressible property of liquid. Now, which is why we use liquid in the hydraulics. Okay, now see. In the hydraulics, I apply a small force here. F1. You got force, you got pressure, you got force, you got area. So pressure is force over area. F1, A1, P1. Now, by applying a small force, then you have created pressure on the liquid here. Okay, so the pressure acts on the liquid. Then it comes to the property of pressure of liquid. What are the main properties? A few properties of liquid pressure. Number 1, same level, same pressure. Number 2, pressure in liquid acts in all directions. Right? That means the moment you press here, the pressure on the liquid applies everywhere. Here, 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 and also the bottom of the larger piston. Okay? Now, let's say I press this piston down for a certain distance, D. That means I'm pushing this much of liquid out of the way. But where will it go? This container all is closed already. There's no way out. I'm pushing this much. It has to go somewhere, right? So the only exit is to rise here. This amount, whatever is the volume, let's say V is V. Because there's no other ways for the liquid to go, and you cannot compress the liquid. If this was gas, 如果这个是 gas 啊，我这里按下来，这里会上吗？ Not necessarily, because I can compress the gas. Right? I can press down here. This one will stay at the same position, not rising. Because if this was gas, when I compress, all the particles can be squeezed. The other side, there's no rising. But if this is liquid, because of incompressible, when I press, then this has to rise. Okay, because there's no room for to accommodate this volume of liquid. Okay, so we press this. Now that's the first thing of hydraulics. When you apply pressure here, this must rise. That's the first point. Now, second, here you know the pressure acts in every direction. The walls and then also the bottom of the piston. What is the pressure here? P2. In the Pascal principle, it says the pressure is transmitted equally throughout the liquid. It's the same everywhere. Whatever pressure you apply here is the same being transferred on the other side. There's one condition. There can be no air bubbles. 你不可以有 air bubbles. Why? Air bubbles is air. So if you've got air bubbles, you apply pressure here. Let's say you apply 100 bar pressure. 10 is used to compress this one. Another 10 is used to compress this one, compress this one. So now reaching here, how many? 70. 30 is already lost to compress the air bubble, which we don't want lah. So it's pressure loss. If you have air bubble, it's going to affect the performance. How much pressure you apply here, you will not receive the same amount on the other side. Okay, because air bubbles, the pressure is not compressive. Okay, that is the only one condition. So let's say that is why this whole thing must be airtight. Fully filled with liquid and fully closed. Okay, so the pressure. Then the pressure, same, right? So I will write P1 equals to P2. Here and here the pressure is the same. Who says that? This Pascal guy says it. Okay? So he says that the pressure must be the same here and here if there's no air bubbles. Alright, so from here we do F1 over A1 equals to F2 over A2. Okay, this one becomes your first formula in finding area, finding force, or even finding diameter of the distance. Okay, now, for example, here I put area 21 cm square. This one is 100 cm square, 4 times larger than this area. I apply a force of 20 newton. What is the force I get from here? Or what is the maximum mass that I can carry on the other side? Okay, so from here, 20. A1, 422 over 100. Divided by 20. Okay, so we get this one. This one is 18 Newton. You get 18 Newton by applying 20 Newton. What happened to your force? It is being multiplied. By how many times? 18 divided by 20 is 4 times multiplier. You see how I get 4 times multiplier? My area increased 4 times. 25, I make the area bigger on the other side. 4 times increase in the area, my force 4 times increase. If I want 10 times, 10x the force here. How much area I need? 10 times the area. Okay, same thing. If I make my area 250 cm square, here I will get 200 Newton. That is why any value of force can be multiplied, can be amplified. And it's up to you how much you want it to be amplified. You may have seen videos on hydraulic press. They put many objects, any object on the hydraulic press will be crushed. Okay, because that is how strong it is. There's technically is unlimited force because you can make the area bigger. You keep on multiplying the forces. So it's the same system used in airplanes, half power steering. Okay, each end of steering is very hard to turn. Now in a hydraulic system, it's very easy to turn. Small force can produce large outcome of forces. Right. Another question we got. Does that mean I can keep on multiplying the forces without any downside? I can keep on 10 times, 20 times, 100 times. What is the downside? Does that mean that if I keep on increasing the area, I will get more and more force? Okay, so we want to see what is the disadvantage, downside. This part, you have to look from the perspective of energy. Now, we know the basic law of energy. Conservation, energy that you put in, you get out of the system must be the same. It cannot be more than that. The energy in equals to energy out. Now, in physics, energy is related to work. F times distance. I'm not sure whether your teacher will teach you this one. Maybe the next chapter. Okay, so let's just talk a little bit about work. It's very related to energy and it's related to the hydraulics. Now, work is force times distance. What does that mean? Let's say you apply force here. This distance will push down. So you have distance travel. You got force, you got distance, you got work. So you are doing work. Okay, according to physics, then you are doing work. If I apply a force and it's moving, then I'm doing work. If I'm doing work, that means I'm giving energy. I'm putting energy in. Okay? So make it simple. You press here, you're putting energy in. Okay? Now, energy is conserved. So energy in must be equal to energy out. So work in equals to work out. Can we put this one in? Force times distance, 1 equals to force times distance, 2. This one you get the second formula. There are only 2 formulas in this part. Okay? The energy you put in must be equal to energy you get out of it. Now, taking the same example, I apply 20 Newton, right? Let's say it comes down 10 cm. Can we find how much this one rises on the other side? Yes, using this one. Force 1, 20 into 10 cm. Force number 2, 18 into D2. So D2 equals to 200 divided by 80. This one you find 2.5 cm. OK， 这个跟你讲什么 ？D2 等于2.5 cm。当 piston 那边 rises by 2.5 cm. Here, when it comes down 10 cm. How many times is this one? Again, 4 times. 1/4 of 10. So that means the distance traveled by the piston is already decreased by a factor of 4. Okay? So that means that overall, you increase your force by 4 times. From 20, you get 80, but your distance traveled decreased by 4 times. That is the downside. Okay, that is the trade-off, the downside. So that means every time you push this one, you push down 10 cm. Here only rise a bit. You don't get the same distance travel. You push down so much, you push down 40 cm. How much it rises there? Just 10 cm. You push down another 40 cm, another 10 cm, another 10 cm. Yes, you get very large force, but this one is very slow. So, yeah, come on. Yes. Okay, so where do you see this? Again, the hydraulic jack of the car. If you want to jack your car up, same. You use the hydraulic, notice that you have to push many times. The car slowly rises like this. It is the same principle using the hydraulics. So you have to keep pushing, but then the car only rises a bit. Yes. Okay. Why we use oil but not water? Number 1. Question that they will ask you. lubricating properties. Okay. Number two, high boiling point. If you use water, when all these things is working, it will release a lot of heat energy. Use oil can reduce the heat energy because you reduce friction. If you use water, let's say you use water, the heat will boil the water, turn into gas, and now you get air bubbles. Okay, so high boiling point is the reason we use oil. Second one, okay, lubricating properties, high boiling point, and also anti-corrosion. Water got oxygen, can corrode, can make the hydraulics rust. So again, oil property, one property, anti-corrosion, we just fit perfectly for the condition of the hydraulics.